Hey math fans, we're on section 2.8.1. Let's get started. This section is all about adding, subtracting, multiplying, and dividing functions. It's pretty self-explanatory, but it gets a little bit tricky, especially the subtracting part, and then we'll talk about double distribution for when you're multiplying. Also, the last tricky part is that when you're dividing, the denominator cannot equal 0. So in example 1, I have two functions. F of x is equal to 3x plus 2, and then you have g of x is equal to 2x minus 7. What is f plus g of x, and how do you represent this algebraically? It's pretty straightforward. When you have f plus g of x, f of x plus g of x is going to be your answer. You're just going to add the two functions together. F of x is 3x plus 2. G of x is 2x minus 7. You combine like terms, so you're going to get 5x, and then you have 2 minus 7. You're going to get negative 5. So your final answer is 5x minus 5. Example 2, 3 to the x, g of x is equal to 5. It says, what is f times g of x, and how do you represent this algebraically? There's not too much to this problem, except there's one consideration, which is when you're multiplying, remember that if you have an exponent like we do here, 3 to the x times 5, they cannot get multiplied. Okay, I can't just make this 15 to the x power, because these are not equivalent. And that's based off of your order of operations. So please, please, please just leave, if you have an exponent as your final answer, just leave it like that. Here's another problem, and I would like you to do this along with me. I'm going to show you a method called double distribution, and this is when you have a binomial, which means that there's two terms, times a binomial. So how does double distribution work? Well, when you have a binomial times a binomial, you got to multiply each term one at a time and make sure that each term in each binomial gets multiplied. So what I'm going to do first is multiply the opposite of x times 3x. And you get negative 3x squared. Then multiply the opposite of x times 2, and you get negative 2x. Once you've multiplied the first term times each of the terms in the second binomial, I'll just cross it out because I know I've already finished multiplying that one. Next, let's multiply 5 times 3x, and you get 15x. And then you multiply 5 times 2, and you get positive 10. Last step is to combine like terms, and you get negative 3x squared plus 13x plus 10 is your final answer. And that is the result of when you multiply f of x times g of x, a binomial times a binomial. Example 3, if f of x is equal to 2x minus 3 and g of x is equal to 4x minus 11, what's f minus g of x? So a lot like the other two, we're just going to kind of do what it says. We're going to subtract f of x minus g of x. So what is f of x? 2x minus 3. What is g of x? 4x minus 11. And once you have 2x minus 3 minus the quantity of 4x minus 11, there's really a negative 1 on the outside of the second set of the parentheses, and you have to distribute that negative 1. So what is negative 1 times 4x? Well, it'll be negative 4x. What's negative 1 times negative 11? Well, it will be positive 11. So please be careful when you are subtracting, make sure that you are distributing that -1 to the second group or that second function. And then you combine like terms, you get your final answer is equal to -2x plus 8. Example 4 has f of x is equal to 2 to the x, g of x is equal to 3. What is f divided by g of x? The big deal with this one is you cannot divide by 0. So we have to be very careful that there's no case where g of x will be equal to 0. And we're in luck because it's just a constant number of 3, and 3 is not 0. So we're going to be fine with this one. So your final answer here is going to be 2 to the x over 3. And there's not going to be any scenario where the denominator is going to be equal to 0. So you just leave it like that. Even if these terms, like if this was 3 to the x over 3, you would just leave it. You just leave it like this. This is already simplified. What if we were working with the two binomials in the other problem? Well, this creates a case where we could have a denominator equal to 0. So f of x divided by g of x will be the opposite of x plus 5 in the numerator and then 3x plus 2 in the denominator. However, there is a value for x that would make this equal to 0. So how do you figure out what that is? Well, you set the denominator equal to 0 and solve for x. X will be equal to -2 over 3. So I would say this is the answer to the question f divided by g of x, but x cannot be equal to -2 over 3. This is called a domain restriction. And that's going to do it for this section. We'll see you in class.